Yeah. So starting with solutions. So the reason why I say it's like perfect chapter for the summers is because you will be dealing with a lot of solutions in the next couple of months. Okay, so this is your first physical chemistry ka chapter, and so like physical chemistry, treat it like a physics chapter. You have a lot of formula and concepts, but questions you'll have a lot of numericals. You've already done like last year, just equilibrium tha, thermodynamics tha. So it's gonna be pretty much like that when it comes to questions and all that. Now coming to the chapter itself, it's all about solutions. What do you guys remember about solutions, जो अभी तक 10th 11th तक जो that you studied?
Solute and solvent.
Solute, solvent, excellent. Yes. What else do you remember about solutions?
Molality, normality.
Oh yeah, absolutely. That's how we
Solutions can be heterogeneous or homogeneous.
close, but see, solutions are always homogeneous only. If they happen to be heterogeneous, you don't call them solutions, then it becomes a colloid, it becomes a suspension. But yeah, mixtures can be homogeneous, heterogeneous, but when it comes to solutions, they're all homogeneous only. Solutions. Do you guys remember solutions? The basics of it, of course, they are made up of a solute and a solvent. What do you mean by solute? What do you mean by solvent? So which one do you call a solute? Which one do you call a solvent? Yeah, किसी को भी कुछ भी बोल सकते हैं क्या?
The one in larger quantities is the solvent.
Correct. So if I'm talking about a salt solution, किसमें बनाते हो? That's the solvent. And what you put in it to make it, that's the solute. Okay. So smaller, larger, even if they're almost 50-50, like the medium where you make them is the solvent. And what do you put in it in order to make that solution? So usually that happens to be in smaller quantity. That's the solute. Okay. Do you guys remember the characteristics of a solution? Like properties, characteristics, what does it look like? What is its behavior? Basics.
Transparent.
Yeah, Kaveri?
Transparent.
Transparent, yes, absolutely.
Gravity does not have an effect on it.
Absolutely. I think it's taking some time, but like these are basic introductory stuff. Kind of just know it in order to be able to like proceed. So they're transparent, yes. Gravity does not have an effect, matlab they're stable, like nothing will settle down at the bottom essentially. That, yes. What about properties with light? Does it do anything to light? Does it affect light?
Does not show Tyndall effect.
No Tyndall effect, which means, what do you mean by Tyndall effect?
Pass
Light will, yeah.
Okay, it does not show Tyndall effect, matlab there's no scattering of light, but what will happen to light? Like if I take a solution, if I pass a beam of light through it, will it pass through? Will it get reflected backwards, or nothing will happen?
unchanged, like the same path it will follow.
Yeah, that is the meaning of transparent, right? Like there's a glass signal there, like it'll just pass through it without any hindrance as such. Maximum refract hota hai, but that's about it. A beam of light will pass straight through. What else? Stable hai. Can you separate the components by filtration, the solute and the solvent? No.
Miss, what was Tyndall effect?
Tyndall effect is scattering of light. अभी इसके साथ I don't think I can show Tyndall effect. यहाँ पे कुछ दिख नहीं रहा है ना? But imagine if, the bottle starts glowing when I put the light here.
Yeah.
If at all we take a break, I can like get some soap water or something and I can show it to you guys. But yeah, if at all, when I do this, if the bottle starts glowing, like if you're able to actually see light within this,
Yeah.
that means that light is scattered within the solution. इसलिए दिख रहा है ना? That's what light is, like it goes straight into your eye. So that scattering of light is Tyndall effect.
Okay.
Like where you can see the beam of light. Another example of Tyndall effect is, have you been to any cold place like hill stations or a foggy place winters may? So do you imagine a scene like it's a very foggy night, evening, or there's a street light and then you can see the light in the mist, right? Like whatever the shape.
Yeah.
Yeah, so that's another example of Tyndall effect. वहाँ पे by the droplets, light is getting scattered इधर उधर. That's what is visible to us as a general glow.
Okay.
अभी true solutions में, because the particles are not big enough to interact or interrupt the light, there is no effect. Like light just passes through them. Okay. And another thing, so when you make a solution, do you think, okay, what will happen to the mass of the solution compared to pure solvent अगर रहा तो?
It won't change because the molecules of the solute will occupy the spaces in between the molecules of the solvent.
The mass will not change.
The quantity won't change maybe, but the mass will change.
Yeah, if I take 100 grams of water and I add 10 grams of salt, yeah. So Smera, your quantity will not change, right? What quantity are you talking about? Mass?
Like
Yeah. So
the volume won't change, but the mass will change.
correct. And the volume will not change exactly for the reason Kaveri was talking about. If solute ka particles occupy between the gaps of the solvent particles. So there's no extra space taken up as such. Okay, so volume will not change, but mass definitely will change because you're adding two things together. That's an important point to remember, because coming to molality, all these things that we use for calculation, these are the things we need. We measure the mass of the solute, mass of the solution and all that. But before we get there, there's no Tyndall effect. The particles are so tiny, which is why all these properties, they're stable, no filtration. They're all single phase. Okay, what does single phase mean? So single phase matlab, if you look at the state of matter of a solution, you won't find two distinct things in it. तो या तो फिर solid रहेगा, या तो liquid रहेगा, या तो gaseous रहेगा. How does this matter? What does this mean is, imagine dahi. Where would you classify dahi under, like solid, liquid, or gas?
Semi-solid.
Semi-solid.
Semi-solid is not a state of matter, na? So like you find solid particles also, liquid particles also. So there's like multiple phases there. So that you won't find with solution. So that way you won't have any doubts. It'll be either a solid or a liquid or a gas. There's no semi thing. So single phase. Yeah. Next. A lot of theory before we get to the numerical part, and this is all like just for info, so that when we start talking about it, agar like question mein aaya, numerical mein aaya, so it'll just help you understand ki kya hai wo. Okay. Whiteboard is like practically useless. What it was there. Just fixing this.
Ma'am,
Yeah.
I don't remember the word exactly, but I remember like in ninth or whatever when we learned this, there was something called some motion which starts from B, which like through
Yeah.
solution. I don't know
That's
what it.
called Brownian motion. Yeah. So that's just like liquid or gas ke particles are always moving, right? Like this is a fact of nature. Ki atoms, molecules, jo bhi hai, they're always moving all of the time. So the random motion that liquids and gases show mostly, so that's called Brownian motion. Solids में Brownian motion नहीं होता है. Solids में again they're all rigidly packed, right? So right in their space, like wherever they're placed, that's where they'll like vibrate fast. There's no random motion ki idhar jao, like that sort of motion is Brownian motion. So that you find in liquids and gases.
Even colloids and suspensions would show Brownian motion.
Yeah, of course. So colloid suspensions, I mean, you would classify them as liquids or gases, right? Yeah, solutions, colloid suspensions, whatever it is, anything that's in liquid state or gaseous state will show that motion.
What is the name of the motion again?
Brownian motion. So I think Robert Brown or someone observed it or talked about it. He was the first one to theorize about it. That's like it's named after a person, not a color. Yeah. Figure out how to fix this. Okay. Okay, so the first part is classifying the different solutions. So solutions classify करने के लिए, again depending on context, depending on what you want to use, like why do you need the classification, there are different ways you can classify them. The first method or basis for classification is what do you take as the solvent. Yeah. So depending on what you take as a solvent, you have one is aqueous solutions and the other is non-aqueous solutions. This is pretty straightforward. What do you think aqueous solutions would be?
Dissolved in water.
If something is dissolved in water. Examples of aqueous solutions? Guys, aqueous solutions you don't know?
Aqueous KOH.
Aqueous KOH, yes.
Aqueous, NaCl.
Aqueous NaCl, that's basically your salt water solution. ORS.
Salt water, sugar water.
Yes, sugar water. All solution, sugar water.
Aqueous ammonia also.
Aqueous ammonia, yeah, like
It has a name, no? Liquid ammonia and there's one more name for ammonia. There were two I remember.
liquid ammonia is just ammonia that is liquid.
Liquefied. And then there is another name for ammonia like dissolved in water.
So you have ammonium, like ammonium hydroxide is what is formed in that case when you dissolve ammonia in water. Uska naam, we'll look it up and see.
Yeah.
So ammonia and water. Toxic to aquatic life, ठीक है. Ammonia and what is called ammonium
Liquid,
hydroxide. Huh?
liquid ammonia.
That is ammonia but liquid form. Like water का solid को ice बोलते हैं वैसे.
Anyway, salt solution, sugar, water, any acidic solution, basic solution like aqueous, KOH and all. So if you dissolve in water, that's an aqueous solution. Non-aqueous are not dissolved in water. Matlab, they can be dissolved in substances other than water. Like ऐसे भी solutions हो सकते हैं. Can you guys give me example? We came across one of them, like haloalkanes made was a reagent. Who remembers?
Example of
It's called liquor ammonia.
Liquor ammonia. Okay.
Yeah, liquid ammonia is ammonia liquefied, and liquor ammonia is when it's dissolved in water.
That is NH4OH. Okay, so colloquially must be called liquor ammonia, right? Okay, now coming back to things that are not dissolved in water.
Oil.
chalk.
Like a single, huh?
Chalk.
What is that again?
Chalk, CaCO3.
Chalk. Chalk is not a solution, no?
Yeah, but like if we dissolve it in, it won't be dissolved in water. Na, if we put it.
फिर वो precipitate है, फिर solution ही नहीं बनेगा classify करने के लिए. That's a suspension, no? It's just suspended.
Yeah, so
Urea, no. Is urea soluble in water?
Again, soluble in water मतलब पानी में you're putting it ना, वो तो aqueous solution हो गया. क्या कावेरी?
You said it would be a suspension, like chalk in water, sand in water, whatever. That would be suspension. But isn't that what we want? Like what doesn't dissolve in water will become.
No. We want a solution in which water is not the solvent. Like it's still a solution. We are putting one substance in another substance, but usually हम पानी में डालते हैं ना, acid, bases, salt, sugar जो भी है. So we are not using water in that case. We're putting it in another something else. I'll start off. I'll give you an example. Alcoholic KOH. So इसमें solvent is alcohol. You're taking alcohol and you're putting KOH in that. So this is not a water-based solution. It's an alcohol-based solution. We're looking at examples like that.
Any non-polar solutes in CS2?
Yes, pick anyone.
Methane.
Methane and CS2. Okay. Carbon disulfide. Solution of benzene and toluene.
Ma'am, you're asking for a solution and then we try to dissolve the solution into water and then that doesn't happen.
Solution, मतलब it's solute plus solvent, ना? उसमें अगर solvent is water, then it's an aqueous solution. But if solvent is not water, it's something else, then it's non-aqueous, like non-water-based solutions. Like alcoholic KOH is a solution, जिसमें solvent is alcohol, ethyl alcohol, C2H5OH, and solute is KOH. So similarly, this particular solution, see, like methane, yes, non-polar hai, but because methane is gas at room temperature, it would be difficult to prepare this. So something that's liquid state in C, like think of CCl4 in CS2. That's another example. So you're taking carbon disulfide as your solvent. Usme you're putting like a little bit of CCl4. So benzene and toluene, like you take certain amount of benzene, mix a little bit of toluene in it, that way. So stuff like that. So whenever you take any solvent that is not water, a lot of organic reactions happen in like non-polar solvents, right? So when you prepare a solution in order to do one of those reactions like alcoholic KOH, that's the thing. Smera, do you remember last year S block elements may there was a solution that you took that turned blue in color when you put S block elements in it. Do you remember what is that?
I don't remember that chapter. It was so much theory heavy.
Yeah. So there was that something ammonical something.
Yeah, ammonical something.
Mm.
We had a whole topic, na blue black solutions of ammonia.
Yeah. So that in that case, you take ammonia as a solvent and then usme you're doing the reaction. Yeah, like more examples as well.
Ammonia, doesn't liquid ammonia like dissolve any base? I don't know.
Yeah, liquid ammonia, if you dissolve something else, like if you can. What's that?
Liquid ammonia is supposed to be a good, not base, sorry. Alkali metals. Liquid ammonia is supposed to be a good base, good solvent for those, right?
Yes, that's what we're talking about S block KDA. So you take liquid ammonia, mix alkali metal in it, and that gives off there's free electrons in it. That's why it has a characteristic blue black. Like there's a whole thing that's a prop like that happens because of S block thing. But the point is, since we're talking about solutions, I wanted to remind like that is a thing that happens in ammonia as the solvent. So the solution that you prepared would be a non-aqueous solution. That's another example. Okay, so this is one basis of differentiation, aqueous, non-aqueous. Usme you see what is the solvent that you take. Next, we have based on the number of components. So you have binary solutions. Then you have ternary solutions. And you have quaternary solutions and so on. This is pretty obvious. जैसे तुम्हारे polynomials होते थे ना, you have like binomial, trinomial and all that. That way, same thing. Binary solutions may, if you have two components, like the examples we just discussed. Ternary solutions may you have three components. So can you think of any example of ternary solution? ORS, or your homemade ORS where you take water, put some salt, put some sugar. When you're ill, when you're sick, like you need to hydrate. So you put three components. You take water, then you have salt, you have sugar. So that's an example of ternary solution. And similarly, quaternary may if you have four components. उससे ज़्यादा you don't come across so much. Even quaternary, I can't think of any examples as such off the top of my head. Binary is what is the most important. Whatever solutions we study about are all going to be binary solutions, whether it's solid in liquid or gas in liquid. Okay. Yeah, Kaveri, what's up?
Will sugar and water be, will glucose and water be a ternary solution?
Why? How many components are there?
Like in the whole thing or just the solute?
No, solution. Like pura solution mein how many things are there? Like recipe mein kitne ingredients are?
Things means molecules or just the elements?
Components, like the substances. Like how many substances are you mixing in order to create that solution?
One.
How? Which one?
C6H12O6. Like, will that be counted as 3 or 1?
No, one. Like, no, actually you have two. If I take only glucose, I'll just have glucose with me. Solution,
like
basically I have glucose and water. So two things.
Can you give an
a quaternary solution?
Tea. Actually, you're adding water, milk, sugar, and tea.
Yeah.
That's a good way to think about it, but unfortunately, tea is a colloid. Like coffee, tea, all of these things are colloids, like pure solution. Maybe
What
without
are
milk,
colloids?
huh?
What are colloids?
Colloids. Acha, Arya, like, can you tell me where did you study till 10th? CBSE, ICSE?
ICSE.
Ah, okay, cool. Because some things like CBSE mein hote hai and then kind of take it for granted ki okay, you would have studied in it. So yeah. Okay. So colloids. So when you mix two things, right? Either there'll be solutions or there'll be colloids or there'll be suspensions. Solutions are like salt water, like they just disappear off in the liquid. Suspensions are, think of sand and water. So you put sand and water, like it's a mixture of sand water, like in pura mix nahi hota hai. Like it separates out or
Yeah.
it's like muddy, it's like completely opaque, right?
Yeah.
Colloids are somewhere in between. Uh, Imagine like just take a glass of water, put some milk in it. Pura diffuse ho jata hai na? But still it's not a complete pure proper solution. क्योंकि milk particles suspended है पूरे पानी में. But they're small enough that it's not like sand and water जैसे filtration से separate हो सकता है या फिर
Yeah.
settle हो सकता है. So colloids are like between solutions and suspensions. Okay. So
Thank you.
yeah, so this chapter will be focusing on solutions. Colloids also we have a whole like बाद में surface chemistry में will be dealing with colloids only mostly. And the suspensions we don't really care about because we can just separate them into two things and like study about them separately. There's no significance with suspensions. But yeah, colloids and solutions are special things. We'll study more about that.
Wow.
Yeah, but black tea, if it's like transparent and all, that might be considered as again somewhere between colloid and solution. Not sure. It depends on what it's made of, size of the particles. Yeah, Kaveri, what's up?
When you say components, you mean the like both solute and solvent, right?
Yeah, minimum 2 to hona chahiye. So along with solvent, that's a good point I'll write here. So the two components are one solute plus one solvent. So when it comes to three components, basically we have two solutes plus one solvent. Okay, so in order to make the solution itself, what all are you taking? So we're taking a solvent to mix in. And apart from that, if you're taking two other things, so we have three components, it becomes a ternary solution.
And ma'am,
Yeah.
is it possible ki if we add more number of solutes, then the mass of this, then the mass of the solute passes the mass of the solvent?
तो फिर वो medium solute हो जाएगा ना? Then it'll be like a solid based solution. Then the solute itself will be called the solvent क्योंकि उसमें mix कर रहे हैं. अगर इतना और ऐसे भी हो सकता है, you can have one solute plus two solvents. Okay, so total three components मतलब two solute, one solvent हो सकता है, which is what ORS is. I'm taking water and I'm mixing two different things of smaller quantity into it. Or I can take a mixture of two solvents. Like if I take water plus, I don't know, HCl or something, equal quantities, and then I put something else in it. Or water plus alcohol and something else in it.
How come something solvents? How is that possible?
Solvent is a medium, na? I'm just giving you the examples of these. Two solvents, matlab, I can take a mixture of water plus HCl or water plus alcohol and then put something else in a smaller quantity in it.
But even if I have two solvents, I have to mix them and make one solvent, right?
Yeah, but total I have three components. Now I have three different substances that are mixed in the solution. That's why instead of getting into the nitty gritties of what are the solutes, what are the solvents, we define it as how many components am I using in order to make that.
And ma'am, we say like the solvent has the maximum like mass. So,
That's
so if so if we have two solvents, so how do we compare which has greater? Because one would still be less if one is less.
50-50 हो सकता है. Like again, that increases the complexity, which is why we are not going deeper into ternary solutions. That's why we are sticking to binary solutions only. Okay, 4 components, again, increased level of complexity. You can put like 3 different solutes in one solvent only, or again you can mix 2 solvents and then put 2 different solutes. जो भी हो सकता है. You have 4 things that make up the whole solution. 4 components. Okay, and the next way of classifying solutions is based on physical state. So textbook mein there's like a whole table given. I'll just put it up all in one ka jo hai, so that you can check it here.
Ma'am, could you once repeat what was the first and the second base of classification?
So this is based on the what is the solvent that we're using. Are we using water as a solvent? Are we not using water as a solvent? So this is based on the number of components. So this is number of components. This is based on the solvent. Solvent, is it water or not? Yeah. Number of components based on like kitne components hai, you can classify it as binary, ternary, quaternary. And the final way of classifying is the physical state. So you have, I think you guys are noting down. Khatam hone ke baad, let me know. Isme you won't get major questions. Maybe you might get like 1 mark questions and things like that, where you'll be either asked to classify it or you'll be asked like identify kis tarah ka solution hai. That's it.
Can we write the whole thing?
Not necessary. Like class ke baad, it's there in your textbook, so you can like note it down, look at it, note it down. Otherwise, no. So this is just to give you guys an idea. You have solid solutions, just make solvent is the solid. So if you're trapping gas in solid, that's a solid sol. Example is when you're putting hydrogen in palladium. Like this sort of you will create this for hydrogenation reactions. And that is one application of it. Another application is to transport hydrogen. Like you'll trap hydrogen in solid palladium. Easy to transport because palladium is solid. And when you want to use the hydrogen, you'll just like heat it up or pressurize it. That's it. Then liquid and solid. So liquid mercury, when you're mixing it in sodium, amalgam is like alloy of mercury, right? So when you're putting mercury in sodium, that's an example of a solvent where you put liquid and solid. This is a popular question because when you think of a mixture of mercury and sodium, intuitively you'll be like mercury liya and then you're putting sodium in it, but that's not how it is formed. You take sodium and then you put bits of mercury in it. And why is it an example of solid solution is, I'll show you an example. this is what it looks like. It is solid because the solvent is sodium, or usme you're putting liquid mercury in it, which kind of changes the properties. So amalgams are mainly solid, even though mercury is a liquid.
Ma'am, we can still see the all-in-one wala page.
Oh. Oh. Yeah. Yeah, we can see it here. All amalgams are, even though they are mixtures, alloys with mercury, mercury is liquid, but once you prepare that amalgam, it's basically a solid, because the other metal usually forms the solvent. Then solid alloys are solutions of solids in other solids. Then liquid solutions, this is what we are most familiar with. Gas and liquid, like sodas, aerated drinks, usme carbon dioxide hota hai, that's the gas dissolved in liquid. That's what gives you the fizz. Liquid, alcoholic beverages, if you add a syrup, squash to water and then make the juice, like that's liquid and liquid. Solid liquid, sugar solution, salt solution, things like that. Gaseous solutions, when you're mixing something in a gas. So gas, like air is a mixture of gases, and it's a solution because the composition is uniform. It's not like either other. Liquid and gas, humidity is the best example. Solid and gas is like camphor, dust or smoke suspended in gas. Yeah. So it's like, is it a solid solution or a liquid solution or a gaseous solution based on the type of matter. These are the basic things. So next we'll talk about concentration of solution. How do you measure concentration? This also you're all familiar with. The first is mass percent. You guys remember the formula for measuring concentration by mass percent?
Mass of solute upon mass of solution into 100.
Yes. So no confusion, all of this. So all of this we measure based on mass of the whole solution. Think of it this way. Mass percentage is kitna percentage of the solution is made up by the solute. So it's a fraction of solute out of the total solution into 100. Yeah. Next, similarly, we have volume percentage. Same thing, volume of solute divided by volume of solution. 200. So mass of solute, like we use mass percentage when you're dissolving like a solid in liquid. You use volume percentage when you're dissolving a liquid in liquid. Like if you want to figure out concentration of sulfuric acid solution, like dilute HCl, dilute H2SO4. It's easier to measure acids in volume because they're liquid state. So you use volume percentage for those solutions. Next, we have mass by volume percentage. So literally in the name, mass divided by volume. So we have mass of solute divided by volume of solution. Other ways of representing this, like m by m percentage. This is v by v percentage. This is, use capital V for solution. Mass by mass, either you can use m by m or you can use w by w, because w for weight. You're weighing kitna mass hai. So if there's w by w percentage, that's basically same as mass percentage. What else do we have? Parts per million. Okay. यहाँ तक note it down. Once we reach parts per million. Right. Arya, Sanskriti, you guys finished noting?
Yes.
Okay. Sia, you finished or still writing? Finished, okay. All right, everybody's done. So parts per million क्या होता है? So all these concepts we had done way back 11th standard में, the very first chapter had all of this. So this is basically a repetition of that. So parts per million क्या होता है?
Parts of one component upon parts of all components into a million.
Yes. Yeah. That's basically it. And the total parts of all components times million. So like why this formula, how this came across, what this basically means is it is how many parts per million parts. So basically you're applying unitary method. So total agar 500 parts mein 300 parts are of the solute, then or one of the components. So total million parts mein how much does that correspond to? So you use parts per million for extremely small concentrations. So things like the dissolved oxygen in water, or if you like, you will come across ppm a lot in when you're doing environmental sciences, chemistry, biology, whatever it may be, when you're trying to figure out dissolved oxygen, consumable oxygen, carbon dioxide, stuff like that. Okay, so that's parts per million. Then fifth. Oh, good. Okay, these are the ones. Okay, yahan tak they're mainly there, like I'd say for the sake of numericals. These are the ones you will use the most often. 5, 6, 7. So the first one is mole fraction. Mole fraction denoted by the Greek alphabet chi. I'm gonna attempt writing again, see if this works out. Still not. Oh god. Okay. So mole fraction, quite simply, is the fraction of moles. So it's number of moles of the component that we are looking for upon total number of moles in the solution. So if you're making up a solution with 5 moles of A and 3 moles of B, the mole fraction of A is 5 upon 8, mole fraction of B is 3 upon 8. Simple as that. Okay. Next, molarity. Mole fraction, molarity are the ones we'll deal with the most. To some extent, molality bhi aayega. These three are the most important ones. Okay, so molarity denoted by capital M. So अगर कोई भी question में if you see 1.1 M where M is capital, that means it's molarity. What is molarity?
Number of moles of solute by volume of solution in liter.
Any volume? Like, is there anything specific about the volume?
Yeah, in
In
liter.
liters.
In liters.
Yes. This is quite important. Agar ml mein hai, so in order to calculate molarity, convert it into liters and you'll get the correct molarity. So other units, mole per liter hai. So mole per liter equal to capital M. Then we have molality. So if you see that something like question may it is 2.68 M and it is small m, it means it's molality. So your calculations and all, you need to take it, consider it based on that. So what is molality?
Number of moles of solute per kg of solvent.
Yes, solute per kg of solvent in every kg of solvent. So you divide it by mass of solvent in kg. So mole per kg is equal to normality. We'll discuss it later when we come across this. So out of these, these three are going to use maximum number of times. These three are quite important. Mole fraction, molality, and molarity. Okay, so coming forward, depending, like if it's gas in solution, we'll be studying about uska pressure differential kaisa hai and all of that, how it behaves as per the change in pressure. Is the solubility going to increase, decrease, all of that? So those measurements of solubility is going to happen in mole fraction. When it comes to solid, liquid, or liquid, you're going to use molarity and molality a lot. These three.
This molarity for what?
Molarity and molality you will use when solute is a solid or a liquid. Mole fraction also to some extent, but this is like moles per liter when you're calculating like osmosis, osmotic pressure and all, Raoult's law, like whatever it may be. It's always between mole fraction and molarity. To some extent even molality, but these two are even more than molarity.
You can't use molarity or molality for when the solute is a gas.
You can, but considering again, so when it comes to gases, you can, but like by convention, like even when we are talking about how it relates with the pressure and all of that, mole fraction is the one that is usually normally used. Mostly between molarity, molality also, molarity is the one preferred because You just take volume of solution and it's easy to, take something in a 500 ml beaker or a 250 ml beaker. So molality also is less preferred. So molality is used when you want accuracy because you're calculating the mass of solvent. It's not going to change with temperature and all of that. Yeah. So we'll do some questions based on this, get you guys familiar with these these concepts, and then based on the time, we'll start with solubility and like the next part of the chapter. Okay, so has everybody written down these formulae? यहाँ तक हो गया ना? ठीक है. So open Flipper. We'll do questions based on this, based on concentration. So the seventh topic, we have solutions and types of solution. There's only like 4 questions, so let's finish that off quickly. So join this live session. 6, 1. Two, 8. Okay, Sia, Smira, Kaveri, Arya, and Sanskriti. Sanskriti is in. अच्छा, before we start, like we didn't meet after last week, no? Did you guys update your app? बीच में कोई update आया क्या? No? Can you quickly check what version you have? अगर Android है तो you're supposed to have version 1.10.
This is showing wrong live code.
614428. You entered this only, Pakka. Enter it again.
Sorry,
Enter it again.
I did.
No. Can you check what version you have? Because you're supposed to have version 10, like 1.10 होना चाहिए. If you don't have that, you have to update it. Update होना चाहिए. Check it. Arya, what's going on?
Saraswati. I have the updated version. Still not.
Enter it again, like you're out of the app, right? So get in again and enter the code. There must have been a typo previous. Are you joining again? Arya?
Yes, ma'am. It says updating now on its own.
Yeah, update hone do. There's only 4 questions. If you want, you can join in for the next topic when we actually start doing this. Yeah. Still, the code is there. You can always come in. In the meantime, okay, everybody else, choose the correct sentence from the following. So, we have 4 statements all about solutions. Abhi tak jo discuss kiya. Read it, figure it out. Okay, 3 people have already answered. Kaveri, you have to choose the correct one. Okay, everybody's done. So yeah.
I think for me, so I might go wrong because it's just changing slightly.
Nice. So Sanskriti, you forgot to put double confidence. Or were you not confident?
Yes, I forgot to put double confidence in that.
Okay. Next question onwards. Do it. Okay. Based on particle size.
Yes, I can't even click join live now.
कहाँ पे? Check. Show me your menu. क्या हो रहा है वहाँ पे?
It's not.
Just give it some time. Maybe it's like a network thing. इसलिए थोड़ा delayed connection हो रहा है.
Ma'am, I'm sure it's an app thing.
4 लोग तो connect हो गए and like other grades also have been doing the live classes. What phone are you using?
Samsung A10s.
A10.
So the phone is also old. It's fine.
No, how old is it?
3 years.
3 years is not that. I mean, like Android 5 say it should be fine. 5 came like what, some 7-8 years ago.
Ma'am, what are these options? How are we supposed to do the particle size?
I did not understand.
Okay, so based on the particle size of the components, which of the following is the incorrect order? So all of these are solutions. They're basically mixtures, solutions, you're saying. Like sugar solution is sugar and water. And then you have paint. Paint is also a form of, it's basically a colloid. So if you look at the particle size in sugar solution versus the particle size in paint, in which case do you think will have bigger particles? Sugar, yeah, paint, right? So that's what is given here. Like sugar solution is less than paint. See, a paint is
How are we supposed to know like whipped cream ka and asphalt ka?
Think about it. Like if you
That.
Ma'am, see, according to like the texture, like you can tell which is like more towards the solid side, more towards the liquid side. But how can we conclude that that's solely because of the particle size? That maybe because of how well the particles are packed, right? May not necessarily be the size of the particle that is causing that.
again, these are all these are all examples of, they're all mixtures. They're not made of a single thing. So even the texture and all will definitely depend on the particle size, definitely. Because if they're all big particles, like if you have small particles mixed in big particles versus big particles mixed in big particles, packing में थोड़ा अलग होगा ना. Think of if you're putting table tennis balls, you're packing table tennis balls and cricket balls versus marbles and cricket balls. How you pack where the balls are arranged will differ in both the cases. Na? I'll do this with you guys. 2 people have answered whipped cream and asphalt. Asphalt में क्या होता है?
It's like petroleum.
Some petroleum thing, and it's basically coal tar. That's why, like, it's the stuff that roads are made of. Okay.
It's
So
like
tar and crude oil. Yeah. And whipped cream. What do you think whipped cream is made of?
milk.
Only milk? Like, how is a whipped cream different from your normal cream?
Condensed milk. I don't know. I can't cook.
Whipped
Air bubbles.
air. So whipped cream is called whipped cream because you're whipping with a whisk or a fork or whatever. What you're doing in that is you're introducing air in it. So things like whipped cream, meringue, like all the fluffy parts of the desserts you have are basically colloids or emulsions of air in the whatever liquid you have. Okay. Now whipped cream is made of literal air in the cream. Asphalt is made of coal tar and like petroleum. So particle size may, do you think the order given is correct or incorrect?
Correct.
It's correct. Na? Asphalt is greater. It has a greater density and it's made of literal like.
I do not understand what is
Ma'am,
asphalt.
how would you know between?
How would you know? Matlab, again, you just need to know what these
No,
are.
I was asking something else.
Yeah, what?
I was asking how would you know between alloy and blood? Like alloy is solid.
I chose that option because I was the only one left, but I don't know how that makes sense.
I'm discussing each one by one. Like sugar solution, paint, clarify ho gaya. Now whipped cream, asphalt. So asphalt is what roads are made of, like the black sticky substance, which has a little bit of gravel and like tar. So that is asphalt. Okay, so it's made of like big molecules again. Like you have organic molecules, and you have like gravel and all that, this clean substances. So order is correct. Gelatin versus aqueous NaCl. Does this make sense to you guys? Or should we discuss it?
I understood that.
Yeah, I saw Sia also nodding. Arya, Kaveri, and Sanskriti. Gelatin versus NaCl. Okay. Now coming to alloy and blood. What is blood made of? Like how is blood a mixture? Like what is it a mixture or a solution of?
RBCs, WBCs, platelets, and plasma.
Right? Plasma hai, like all your water and serum. Usme you have RBCs, WBCs, platelets. Versus alloy. Alloy किस तरह का mixture है?
Like tin and all. Two metals.
Two
Yeah,
metals.
combined.
Yeah. So when two metals are combining, so if you compare RBCs to like metal atoms, kisme particle size is bigger, kisme particle size is smaller?
Metal would be bigger.
Metal would be bigger, na? So यहाँ पे the order that is given is incorrect. So that would be the answer that we need.
Alloy greater than blood. Isn't that correct then?
Yeah, won't it be correct?
It won't be correct. Question पूछा है, which of the following is the incorrect order?
Then alloy is given bigger than blood, no?
So between metal atoms and RBCs, WBCs, which particle size is bigger?
Metal.
Huh?
I just said metal.
Metal atoms hai, RBCs hai. RBCs, WBCs are literal cells. Cells that are made up of atoms, which they themselves have like metal atoms. Like RBCs have iron atom in between them, surrounded by like a whole lot of, like they have hemoglobin and they have like other stuff apart from hemoglobin, right? Like chemically speaking. Like think of it, order of the universe. If you have atoms versus cells, which one is bigger?
Cell.
Huh? So that is why this is the incorrect order. Yeah, Arya, I see you have joined successfully. Well, yeah, like a little bit of patience. It'll happen. Okay, next. Somebody had to rejoin again. Anyway, 5 people are there. Okay. Which of the following is or are true for colloidal solid? So you need to pick the true statements. इसके बारे में क्यों है question इधर? Shouldn't be there. Particles cannot pass through animal membrane.
Something passes.
What is animal membrane?
We haven't discussed that yet. Like all of this is osmosis related. It should be
Animal membrane as in semi-permeable membrane. Right?
yeah, semi-permeable. Correct. Guys, flag this question should be in a different chapter. Mention it should be in surface chemistry. Colloid show Tyndall effect. Particles invisible by the naked eye and also under microscope. Then I'll just stop this question. It's not answer this. Okay, this you should be able to answer. Based on the phases of two of these options are incomplete again. Section this needs to be typed again.
How is it income?
Because it doesn't make sense. Which of these is correct? Matlab, it's two
They've
options
given-
may you have the example, two options may you don't.
I can say example in all the options.
Oh, you can see in all of them. Oh, I was not able to see it on my screen. I don't know.
I could only seen 2 of them too.
I guess it's because I have iOS.
It threw me out of the live.
Yeah, because I ended it.
Yeah, same. Oh,
I'm still in it.
Anyway, join this one, guys. 7, 8.
How do you exit the live?
I've ended it. Should be ended. Like it threw all these people out.
Live.
Just exit the app and like come in again. Okay, Sanskriti, Smera, Arya, Sia. Somebody is joining. Kaveri will be done. Okay, ready? Start. Okay, good. So we just discussed this. Solution as amalgam of mercury with sodium. So figure out the phases of the solute and the solvent. Amalgam मतलब you're mixing mercury and sodium. उसमें solute क्या है, solvent क्या है?
If they've said mercury with sodium, then is it in that order or is it like sodium and mercury? Or...
So amalgam is defined as any alloy of mercury. So mercury के साथ कोई भी metal you can mix it with. So that's why when you talk about amalgams, you talk about it in this sense. Amalgam of mercury with sodium. So mercury is default. Again, I just
mercury could be, so does that mean कि mercury is the solvent or?
yeah, so like you need to know what amalgams are. Abhi jo discuss kiya. The order in which this is written doesn't matter. Because amalgams by default are of mercury. So it'll be like mercury with sodium or mercury with zinc or mercury with gold, is it?
I still didn't get it. Is mercury the solute or the solvent?
That is the answer that you need to figure.
But like, how do we know if they've said like, I don't know what amalgam of mercury is. Would the
I
mercury?
literally just explained it to you when we were discussing different types of solutions. So amalgams, I'll tell you what. Amalgams by default are of mercury. So you have sodium amalgam, zinc amalgam, gold amalgam. So that's why it's phrased as mercury of like amalgam of mercury. In this case, we're talking about mercury with sodium. Now you need to figure out solute कौन सा है, solvent कौन सा है. Everybody's answered, ना? ठीक है. So amalgams में हमेशा the solute is mercury. The solute will be liquid. Solvent will be the metal where you're mixing it. So more often than not, solvent is going to be solid. इसमें you're mixing it with sodium. So sodium by default is solvent. So I showed you guys the pictures also, no? Kaveri, you forgot.
Yeah. Sorry.
Yeah. So amalgams always end up being solid. Solvent is solid and the solute is. Okay. 3 people have got it wrong, yeah? Yeah. Which of the following is correct example of solid solution in which solute is in gas phase? So where are you mixing gas in a solid? This again, you can use common sense. Once you know what these substances are, you can answer it easily enough. See, I got it. Confidence ke saath. First one to answer. Sanskriti, very good. Sanskriti, you forgot the confidence again. Kaveri answered. Smera also done. Arya, what are you waiting for? What happened? Or you answered it, it's not showing here. Kya ho raha
Yeah.
hai? Okay.
It's okay. I'll tell you what. It's allowing me to click the option, but it's not correcting it. It's directly showing the solution. So I don't know.
अच्छा
what
नीचे
happened.
सबमिट बटन नहीं है, सॉल्यूशन बटन है डायरेक्ट.
हाँ.
Okay. Rejoin it. Should reset that. Okay, everybody has answered it. Yes, everybody got it. Where are you mixing gas and solid? Okay. अभी concentration based thing, numerical है, calculated, send it.
It's showing the same thing again. It's not showing submit. It's showing solution.
Did you rejoin? Did you exit and join again?
Yeah.
Okay, should get something. square submit. Okay, calculate it and send your answer on chat, abhi, like for this class. Once we do a few questions, like homework mein, to you should be like shouldn't have any issue. Abhi classmate. Okay. So Sia, Smera, Kaveri, and Arya got it. Sanskriti, what's happening?
Ma'am, I think I made some calculation errors, so I'm calculating it again.
Okay. So 18 grams of sucrose dissolved in 162 grams of water. So mass percentage, matlab, yes. So if you got it right. Arya, I got your answer submission, Arya. Sanskriti, क्या हो रहा है? I should have done by now. The formula is also right here. Mass percentage, mass of solute. So what did you take as mass of solute here, Sanskriti?
Ma'am, mass of solute is 18 grams,
Correct. And mass of solution?
is 162 grams.
नहीं. Solution क्या होता है?
Ma'am, this is a solution, sorry, my bad. That is why it was coming wrong.
Solution is both solute and solvent together. उसके बाद like calculation is very gets really easy. चलो जल्दी. Okay, I'll stop. Next, rest of you all got it. So 184 grams of ethyl alcohol is mixed with 72 grams of water. The ratio of mole fraction of alcohol to water is?
What is molar mass of ethyl alcohol?
Can you calculate it? What is the formula of ethyl alcohol?
I don't remember.
Ethyl alcohol, Kaveri, come on, you should know. It's like something very familiar with C2H5OH. And you can figure it out from the name also, na? Ethyl is C2H5, alcohol is OH. We calculate ethyl alcohol. Nice. First one, who was it? Kaveri. Good. You were the one who asked formula for ethyl alcohol with calculation. Followed by Smera. Smera, what happened to the confidence score of you?
I forgot. I calculated and I got an answer.
Sia got it. Cool. Arya, if you've clicked and it's not getting submitted, just send it on chat. At least I'll know that you've finished, you've done the question.
Oh, ma'am, I haven't done it.
In generally, I'm just saying. Sanskriti, what's happening? Calculating? aa raha hai, nahi aa raha hai?
Ma'am, I'm still calculating.
What's that?
I'm still calculating.
Okay. Calculating or still trying to figure out?
No, ma'am, I'm calculating.
Okay. 3 steps. In fact, I'd say only 2 steps. Teesra to pretty straightforward after that. Figure out mole fraction chahiye, na? So you need the number of moles. Figure out number of moles of alcohol, number of moles of water. Rajai. Arya's finished it. Got it. Sansari, did you get the number of moles of alcohol?
Yes, ma'am.
Okay. Calculating the number of moles of water.
Ma'am, water I got.
It's
It's 4. I'm not calculating wrong.
No, once you got the number of moles, question kya pooch raha hai? Ratio of mole fraction of alcohol to the mole fraction of water. So mole fraction of alcohol कितना है? Mole fraction of water कितना है? So दोनों में mole fraction मतलब denominator is same ना? So technically what they're asking is, give me the ratio of number of moles of alcohol to the number of moles of water. Like numerically, that's what it gets equal to. Aya, Sanskriti,
No, ma'am.
where are you stuck? Okay, number of moles of alcohol कितना आया?
Ma'am, alcohol I did 184 upon 34.
34 कैसे? C2H5OH ना? So C2 मतलब 24 होगा. 2 carbon
Sorry,
into 2.
again, silly mistake.
Ah. Yeah, correct it. Like for when you do the pura topic practice, we'll like
Yes, ma'am.
yeah. Okay. Next question. Molarity of distilled or pure water is? So molarity क्या है? The number of moles in 1 liter. So molarity of distilled water मतलब how many moles of water do you have in 1 liter of water? You guys giving it a go, or do you want me to try it? Sorry, do you want me to discuss it?
Ma'am, could you discuss?
ठीक है. So molarity क्या है? Number of moles, like forget about solute solution क्योंकि यहाँ पे we just have pure water, right? So essentially, how many moles of the component we have in, we're dividing it by volume in liter because we want to see how many moles are there in 1 liter of that substance. Okay, so technically the answer to this question is 1 liter of water में कितने moles of water are there? So number of moles calculate करने के लिए you need to figure out how much mass of water is there. So 1 liter of water में how much mass of water do you have?
1000 grams.
1000 grams. Yeah. So figure out 1000 grams कितने moles है? That'll be the molarity. Arya got it already. Sia got it. Smira got it. Nice. Sanskriti. Kaveri is done. Finished. Got it. Sanskriti, can you switch on your video?
Yes, ma'am, I just switched off because your voice started breaking.
Okay. अभी ये question discuss किया ना किया? Oh yeah, you also got it.
Yes, ma'am, I did it.
Cool. Next. Okay. If 0.1 m of silver nitrate and 0.1 m of sodium chloride solution are mixed in the same volume. Same volume matlab if I take 100 ml of the first one, I'm taking 100 ml of the second one. If I take 1 liter of the first one, 1 liter of the second one, that way. Then what will be the concentration of nitrate ions? This is a good one.
What is the atomic mass of silver?
That's okay. I'll give you the information, but honestly, you don't need the atomic mass for silver. You don't need atomic mass in this at all. But for your information, atomic mass of silver is 108. Molar mass 108 grams, atomic mass 108 AMU. Mass number is 108. Again, try kar lo. Agar, like if somebody wants to discuss, let me know right now. We'll start discussing. So once you understand the situation, it's pretty straightforward. It's very easy. Yeah, smiling. What's up?
Can you discuss?
Okay. So first, and like I'll just explain what is happening here. Once you get it, calculation आसानी से कर सकते हो. I'll just like stop this here. Huh. So I have 0.1 m of silver nitrate. What does that mean? 0.1 m मतलब क्या है?
Clarity.
Molarity है. So basically, I'm mixing 0.1 moles per liter of silver nitrate, and I'm mixing 0.1 m, like again 0.1 moles per liter of sodium chloride. And also another information given is they're mixed in same volume. So basically, if I'm taking 1 liter of silver nitrate, I'm mixing it in 1 liter of sodium chloride. Okay, if I'm taking 500 ml of this, I'm taking 500 ml of this. So to keep your calculation simple, whenever you're given these sort of questions where specific volume is not mentioned, assume you're taking 1 liter of the solution. So that way, number of moles and all, three direct numbers you'll get. What will be the concentration of nitrate ions? So specifically, we want to focus on nitrate ions.
So ma'am, mass you will take as 1000 grams only.
Mass क्यों? Like you don't need mass at all. Options also पूरा molarity में ही it's given, right? So molarity के लिए you need number of moles and you need volume. Volume है, and because ये भी number of moles में ही है, you have both the information direct. So you don't need to convert it into mass and all that. वो तो complicate कर देगा. Okay. So imagine this. If I'm mixing ये concentration silver nitrate, okay, before that, if I want to figure out the concentration of nitrate ions in this whole mixture, what is my source of nitrate ions? कहाँ से आ रहा है?
AgNO3.
AgNO3. Only from that. यहाँ से कोई nitrate नहीं आ रहा है ना? Which means total mixture में how many moles of nitrate ions do I have?
Point 1.
0.1, right? Because AgNO3 का concentration क्या था? 0.1 moles in 1 liter. And I'm taking 1 liter of the solution, matlab I have 0.1 moles of nitrate ions, right? Okay, mix करने के बाद total volume कितना है solution का मेरा?
2 liters. Because we took 1 liter.
1 liter of this plus 1 liter of this. So total 2 liters. So now I have number of moles and I have volume. So can you calculate the concentration?
Ma'am,
Yeah, Kaveri.
let's say we had something like AgNO3 twice. If we had, then we know the number of moles of AgNO3 twice, then would we multiply that by 2 to find out the number of moles of NO3?
Yes. So if I'm adding 0.1 of AgNO3 twice, so if I'm looking at nitrate ions only, so each mole of AgNO3 twice is going to be give 2 moles of NO3, right? So you multiply that.
I can't click the submit option. Can you show the code again?
No, don't rejoin because I kind of ended the question.
Oh,
So answer क्या आया final? Just tell me the
0.05.
0.05. Yeah. Okay.
Did you end the slide?
The question only. अभी अगला question आएगा. If you want the code here. What will be the concentration of 0.2 m H2SO4 solution in grams per liter? So m is mole per liter. You need to convert that into grams per liter.
This it's not showing in the next question.
But have some time. Like again, network syncing issues, right? It's just a little slow. Like, is it showing the previous questions, like with the score and all of that? Huh.
Yeah.
Yeah. Once, are you on Wi-Fi or mobile data?
Wi-Fi.
Wi-Fi. Okay. Okay, in case you guys want for reference, hydrogen is 1, sulfur is 32, and oxygen is 16. Okay.
What are they asking? Isn't the concentration already given?
What is the concentration given?
Molarity,
What is molarity?
moles per liter,
And what are they asking?
grams per liter.
So what do we have to find exactly?
So whatever number of moles in 1 liter of H2SO4 is there, convert that into number of grams.
So इसमें also we take 1 liter only, right?
या क्योंकि ग्राम्स पर लीटर है ना, तो 1 लीटर में इतने मोल्स है, तो वही लीटर में कितने ग्राम्स है. One has already answered. Sia has got it already. Good.
So I don't understand how to find out grams per liter.
So moles को you need to convert in grams. What is the relation between mass of H2SO4?
Given mass, basically.
I didn't understand what we have to do.
Same.
Okay, can you guys read the question and explain what is given and what you have to find out?
What will be the concentration of 0.2 molarity of H2SO4 solution in grams per liter? Basically, you have to convert grams. But is it molarity or no? It's in mole per liter. So now we have to convert in gram per liter. So
I mean, okay.
Ma'am,
1 second, Kaveri. So 0.2 mH2SO4 का meaning क्या है?
that number of moles of H2SO4 upon volume of the solution of H2SO4 is 0.2.
Basically 0.2 moles of H2SO4 is dissolved in 1 liter of a solution. मतलब तुम्हारे पास 1 liter solution है, उसमें if you count only H2SO4 you have 0.2 moles of it. That's molarity. Okay, number of moles in 1 liter of the solution. अभी उसको you need to convert it to grams per liter. So see 1 liter में instead of number of moles of H2SO4, how many grams of it do you have? हाँ Kaveri, you were asking.
can I say the answer? Because like I have a doubt.
Oh, let Smera and Arya give it a go. And we'll discuss. अभी आइडिया आया स्मेरा एंड आर्या? Oh, all 5 done. ठीक है. Yeah, Kaveri, what's up?
I got 196 grams, but I chose 19.6 because that was the closest.
Question एक बार से पढ़ो, how many moles?
So like the number of moles would be 0.2, right? And then that is equal to the given mass by the molar mass, which is 2 plus 32 plus.
What is the molar mass of H2SO4 that you got?
$98.
हाँ, so 98 into 0.2 कितना होगा?
Oh, I did 2.
2, yes, you got the right answer, but it's 0.2, so 19.6. Next. Okay. 4 liters of 0.02 m aqueous solution of NaCl was diluted by adding 1 liter of water. Then the molarity of the resultant solution is. This is very good. We're getting like each question of a different type, so kafi getting good practice. Once you guys finish this question, I'll tell you guys a formula that'll help you in these kind of questions.
No, I can't submit it.
Oh, like
Leave it and join again. I did
Yeah.
it like 3
Just
times.
rejoin.
That's the only way.
nice. Sia's done. 3 people have done. Kaveri, Smera, got it. 4 people now. Sanskriti also finished. So you guys got the hang of molarity. That means conceptually, क्या है, कैसे करना है, all that. Arya, what's going on? Where are you at? Okay, oh yeah, you got yours also. Done. Awesome. Yeah. So before we go to the next question, can one of you tell me how did you do this question? How did you approach it?
Can I say?
Nicely.
I said, can I say?
Yes, yes.
So we've been given this 4 liter of NaCl and the molarity of that is 0.02.
Huh.
So the volume of the solution would be 4 plus 1, that is 5 liters.
Hmm.
Then 0.02 is equal to the number of moles by 5 liters. So that we get 0.08. That is the number of moles of NaCl. And then number of moles of water we can find out using given mass by molar mass. That will be
You don't need number of moles of water. Why? You need molarity of the resultant solution. No? So you have volume of the solution and you found the number of moles of NaCl. Dono ho gaya, right? So if you like, did all of you do it in this method, or did anyone else use any other method? Same. Okay. So, okay, first step may, how did you find the number of moles of NaCl?
0.02 into 5.
Basically, you multiplied the molarity by the volume, m into v, right? So whenever you're diluting a solution, or if you're like mixing two solutions or something like that, the number of moles is not going to change, like fraction and all that. That's like one constant. If you have like 0.8 moles of something you're adding there, that 0.8 is going to be constant. That might get added to 0.2 moles of something else or whatever, right? So the like you will use this formula specifically when you're diluting or when you're adding two different solutions. Like यहाँ पे 0.02 m 4 liters of NaCl plus, instead of diluting, they said 1 liter of 0.05 m aqueous NaCl, something of that sort. When you're mixing two solutions of two different solutions, or when you're diluting this, if you have to find out the molarity of the resultant solution, this is the relation. So M1 V1 is equal to M2 V2. This you will use directly when you're dissolving. So M1 V1 is molarity of the first solution, volume of the first solution you're mixing. M2 V2 is molarity of the final solution, volume of the final solution. So numerically also, if you observe, this is basically what you got. Like if you have to figure out what is M2, you did 0.02 into 4 divided by the new volume, which is 5, right? So next time, like if this is like a shorter way, quicker way to do it, this is one. And when you're mixing multiple solutions, you can simply add all of them. M1 V1 plus M2 V2 plus how many ever solutions you're mixing is equal to MV, which is molarity and volume of the resultant solution. One thing you need to be careful is when you're doing this, the molarity volume, like the molarity that you take will be of single substance only. Agar LHS में when you're adding molarity of NaCl ले रहे हो, तो ये भी molarity of NaCl ही होना चाहिए. You can't mix two quantities of like different things. Yeah, and the final result also you'll get molarity of whatever you're adding here. That's one thing you need to remember. That's one thing you need to be careful about. But otherwise, yeah, this is like a shortcut way of doing these sort of problems. So this is when you have dilution, क्योंकि एक ही solution है and you're just adding water. And this is when you're adding multiple solutions of different concentrations. But multiple solutions of the same thing. If I'm taking silver nitrate, पूरा silver nitrate का ही होना चाहिए.
Ma'am, I didn't understand the second formula. Like, could you give an example?
Yeah. So the second formula is like, suppose like this question only, instead of diluting it, if I say I'm mixing 4 liters of 0.02 m NaCl and 1 liter of 0.5 m NaCl. So after mixing, what is the concentration of NaCl? So if you had to go it like conceptually, you'd figure out यहाँ से कितने moles of NaCl आ रहे हैं, यहाँ से कितने moles of NaCl आ रहे हैं, and then you get the total moles of NaCl that you're mixing in 4 liters of this plus 1 liter of this, 5 liters of this, right? So simpler way to do it is like, that's what you're doing. Just put it in a formula. So 4 into 0.02 plus 1 into 0.05 is equal to molarity of the new solution into volume of the new solution, which will be 4 plus 1, 5. All right. Should we do the next question? Okay. Ooh, the molarity of a urea solution in which this much grams of urea, this is the formula for urea, huh? CONH2 twice, is added to 0.3 decimeter cube of water. Do you know how to relate decimeter cube to meter cube or liter or whatever? Do you know what is decimeter cube? How it relates to meter or centimeter? Okay, I'm gonna assume no. Oh yeah, Kaveri. Go ahead.
1 decimeter would be 0.1 meters.
Correct. So 10 decimeters make up 1 meter. So 1 decimeter cube is 10 power minus 3 meter cube, or 1000 decimeter cube makes 1 meter cube. So 1 decimeter cube is basically equal to 1 liter, because 1000 liter also makes 1 meter cube. I'll just put the conversion here, just write it. So 1 meter cube is equal to 1000 liters. Now the relation between meter and decimeter cube is 1 or 10 decimeter equal to 1 meter. So 1000 decimeter cube is 1 meter cube. You can see here 1 meter cube makes 1000 liters, 1 meter cube makes 1000 decimeter cube. So you can numerically you can equate 1 decimeter cube with 1 liter. They're asking molality. Ooh, okay. Convert that water into.
But we need it in kg, right?
So
Not meter cube.
Density of water. So 1 kg per meter cube.
ma'am, can you explain this? I'm so confused.
Okay, so okay, molality. So molality, matlab, what do you need basically end of the day in order to figure out molality?
Number of moles by mass in kg, mass of solvent in kg.
Correct. So molality find out करने के लिए you need number of moles of urea divided by mass of water in kg, right? Okay, numerator. Can you find out the number of moles of urea? Yeah, your given mass already here 0.01 grams divided by, figure out the molar mass.
60.
Divided. Now, mass of water के लिए. So you given volume of water equal to 0.3 dm cube. which will be equal to how many liters? Convert it to liters क्योंकि in terms of density and all, it's easy to figure it out in liters. So how many liters of water? 0.3 liters. So 0.3 liters, कितना mass है? What is the mass of 0.3 liters of water? Density of water कितना है? One what?
I don't remember the thing.
1 grams per liter, 1.
1 gram per milliliter.
Okay.
1 kg per meter cube.
Yeah, meter cube, kg per meter cube.
Kg per meter cube or kg per liter?
Isn't density calculated in
This
kg?
meter cube, yeah, meter cube because mass by volume, right?
One
But
second.
the volume for density is always milliliters, right?
Doesn't matter. It's like, I mean, SI unit एक होगा, but density always relates mass with volume. And depending on what you're given in the question, what is convenient, you can take per cc, per ml, per liter, जो भी है. It's not 1 kg per meter cube, it's 1000 kg per meter cube. Water is easy to remember because, like, if any of you are into fitness, weight training and all, you can use this fact. 1 liter of water is 1 kg. It's a direct relation. Agar weights chahiye, to just get like 1 liter bottles and use those. Okay, just remember that, it's easy. If you want, I can show it to you. Just got this. 997 is the accurate value, but like these questions and all, 1000 kg per meter cube.
We take 1000, no, yeah.
kg per meter cube. लेकिन अभी लीटर में कन्वर्ट किया ना हमने. So 1000 kg divided by 1000 liters. That's 1 kg per liter.
And what are we doing? I'm really
I'm so confused. What are you saying?
This is density of water, 1 kg per liter. Got it?
Okay.
that. But like, what are you doing with this information?
Molality के लिए क्या चाहिए हमें? Number of moles चाहिए, mass of water चाहिए. But question में we are not given mass. We're given volume. So we're trying to figure out a way to convert the given volume into mass. What
Volume
relates to given mass with density?
Ma'am, what is, they've said STP. So is there any relevance of that?
STP basically room temperature, atmospheric pressure. So whatever values you know, that's what you need to use.
No, like, would we consider 22.4 liters or something? Or
That's
no?
only for gases. Like volume of 1 mole of gas is 22.4. Mass will be 0.3 liters, matlab 0.3 kg, because 1 kg per liter is the density. You have number of moles, you have mass. चलो number of moles देखते हैं कितना आएगा. CONH2 twice.
So molality is number of moles divided by mass of water. So to find the number of moles, we did given mass by molar mass for urea. And then what about the density thing?
So for water solution के लिए, what are you given? What information are you given?
Water, 0.3 decimeter cube.
So what is that? Like, do you have mass of water?
Okay.
Ma'am, it's not letting us submit.
Yeah, no, I stopped that question. तो फिर से आ जाएगा. Like once you guys do your practice, boost में आएगा, then you guys can do it on your own. Send it on chat what answer you guys got. Yes, Smira, I got it.
These are answered on the question itself, like in the line.
Kab? Abhi?
Yeah.
Yeah, now it's letting us answer.
Okay.
Even I answered.
For me, it's still not showing.
Okay. You're not supposed to क्योंकि मैंने stop किया वो question. Okay. Okay. Kaveri, Sanskriti, send your answer, guys. What did you get? Yeah. Now, Kaveri, need to check the calculation. So the scale you got it right, like 10 power minus 4 आएगा, but the numbers you got it wrong. So check the calculation. Numerator, denominator, शायद. That's what I got.
Mass of solvent is 0.3, right? And
Number
then
of moles?
of this thing, urea, that is 0.01 by 60, right? Oh,
Yeah.
ulta.
Sanskriti doing it.
No, it's correct. 0.01 by 60. That would be 0.00016.
Don't do the calculation. वहाँ पे 60 है, यहाँ पे 3 है ना. So there's a possibility that it might get cancelled. Even if not, usually leave that till the last moment. तो आसान हो जाता. कर लो जल्दी, then we'll go to the next question, please. Yeah. Now you got it.
Miss, did you like give the next question because it's still showing me the previous?
No, haven't gone. Just waiting for Sanskriti. 0.3. What happens, Sanskriti? Did you get these values? Number of moles itna hona chahiye. Mass itna hona chahiye. What's your final calculation?
Ma'am, I think I did something wrong.
Kahan pe? Tell me what values you got.
Ma'am, yes, I got. Where is it?
Number of moles kitna aaya?
Ma'am, it's 0.01 upon.
Upon?
Ma'am, is it 46?
No.
No, I mean 0.01 upon 46.
No. How I like? Okay, this is the second time you got this wrong. How are you calculating molecular mass? Yes.
Ma'am, for oxygen I took 16
Okay.
and carbon I took 12.
Okay.
hydrogen I took 4,
4 are there, yes.
and if I'm not wrong, I took 14 for N.
Okay, how many nitrogens did you add? 14 or did you add 28?
Oh, sorry, I did one only.
Be a little more careful because 4 hydrogen you did it right. Nitrogen का कैसे miss out हो गया फिर? ठीक है. All right, we'll do the next question, guys. Abhi. Molality of an aqueous solution of urea is 4.44 mole per kg. Molality is given. So in solution, fraction of urea is. So they're asking fraction of urea मतलब इसका mole fraction कितना होगा? क्योंकि molality है, you already have number of moles of urea. So now all you need is number of moles of water. So you can figure out the mole fraction.
What would we consider the mass of the
1 kg, na? So 1 kg in like 4.44 moles in 1 kg. So same quantity के लिए mole fraction चाहिए. Also be careful, mole fraction is out of the total number of moles of the solution. So don't, no silly mistakes there. Just put that under the
solution? The mass is 1 kg or like
water is 1 kg. Mass of solvent है ना?
I'm getting some weird value for number of moles of water.
Can you send it on chat? That is correct. You guys just did this question like molarity of water, mate. Remember?
That was too big to even exist.
Ma'am, I'm not able to submit the answer.
Send it on chat, Smira. Confirm it. Or you can rejoin it. Should be fine for like 3-4 questions after that. Oh, one person submitted. Sia got your answer. Arya got it. Smira got it. Correct.
Now 7.
Yes, I got it here also. Okay, Sanskriti and Kaveri. Right. Sanskriti, क्या हो रहा है? Did you do it? Sanskriti, you have the number of moles of urea, that is 4.44. Did you calculate number of moles of water? Mole fraction के लिए you need total number of moles, na? Four people. Kaveri also got it. Awesome. All of you got it. Confidence के साथ. Nice. Come on, Sanskriti. Where are you? What are you doing, Abhi?
Ma'am, I got the number of moles of urea as 4.44,
Huh.
and then number of moles of water is 18.
Number of moles. 18 is the mass, right? Molar mass है वो. 18 grams है एक मोल में. तो 1 kg like 1000 grams में कितने मोल्स रहेंगे? You getting it? How do you calculate number of moles? What is the formula? Tell me.
Ma'am, given mass upon molar mass.
Given mass upon molar mass, right? So 18 क्या है? What you calculated?
Ma'am, molar mass.
Molar mass. And what is the given mass?
Given mass. 1 kg.
1 kg. So that you need to convert to grams. You can't do 1 by 8. Okay. क्योंकि
Oh,
पूरा एक unit में
seriously.
units. Careful. It's good. Like keep this in mind. So when you do this again, like you need to get the right answers without all of these mistakes. Yeah.
Yes, ma'am.
Okay. Once that's done with mole fraction here. Okay. Next. Okay, when 10 grams of solute is dissolved in 950 ml of water, the mass percent of the solution is.
Just how many more questions?
I'm thinking I'll stop after, like again, mass percent, volume percent, we didn't do a lot of it, no? Finish this question. Like, if you guys got the hang of it, practice in your own time, like over this week.
Miss, how can mass percent be like the options that are given? Shouldn't it be in percentage?
So like 1.04%, 8.3%. 10 grams of solute dissolved in 950 ml of water. आ जाएगा, it's pretty direct. Major crux is the calculation bit of it, वो division करना पड़ेगा. Once you do it.
May do we use density?
Yes.
This 1 ml is equal to 1 gram, right, in pure water.
Yeah. 1 gram is 1 ml.
So why do we need to convert it? Well, like why do we need to use density?
Find
Like
the
1 gram equal to 1 ml, that relation is density से आ रहा है ना, 1 gram per ml.
Oh, okay. Like
1000, no?
No, if you're equating gram millimeters, it's 1:1. 1 kg is 1 liter, 1 gram is 1 milliliter.
M1, M2 you're saying?
Huh?
1:1 is what?
Like 1 kg is 1 liter density of water, and 1 gram is 1 ml. 1000 comes into picture when you use meter cube.
Now what is the density? 1.
1 ml hai, you're converting into grams. So
If we're using milliliters, then it will be 1. And if we're using liters, then it will be 1000.
1 only. 1 kg. So I'll give you guys the list of density. Just make a note of it, put on a post-it or something. Question khatam hone do. One person has already answered. Arya got it.
Okay.
Mera Sia, where you guys at? Division? Or okay. It's like Smira has also done. Oh, 3 people. Cool. Sanskriti, what's going on?
Ma'am, I'm dividing last part.
See, mass percent again क्या चाहिए? Mass of solute. हमारे
Yes,
पास
ma'am,
है
mass
क्या?
of solute is 10 gram. It's already given.
हाँ. Mass of solution. Do you have mass of the
Uh,
solution?
No, ma'am, I calculated that.
कितना आया?
Ma'am, 960.
Again, Sanskriti. Solution क्या होता है?
Ma'am, solution is solute plus solvent.
हाँ. Solute पता है? Solvent is?
Solvent is 10 grams.
Solvent कितना है?
Sorry, solvent is 950 ml.
हाँ. So 950 ml, लेकिन mass of solvent चाहिए ना? So convert that to mass. How much will be the mass of the solvent? One gram per ml. So that also will be 950 grams. The solution will be 950 plus 10, 960.
Ma'am, that is what I said, 960 in the beginning.
Again, oh, I heard it as 950. Okay.
No, I said 960.
960. ठीक है. 960 तो सही है. So then you just have to do the division. 10 divided by 960 into 100. That means you're also pretty much done. बस वो division करना था Sanskriti. You also. Okay. Send the answer. In the meantime, you guys note this down. Oh yeah, right here. 1 meter cube is 1000 liters. This is all for water only. Huh? So it's 1000 liters make 1 meter cube.
Yeah.
These are volume relations, not density. Okay, I'll just put here. Density of water. You have 1 kg per liter and 1 gram per milliliter. So this is all like relating mass and volume in liters, milliliters. that you have 1000 kg per meter cube. So what if you have volume in meter cube, not in liters, SI unit minute? 1 kg per. This you won't get to use it, but since we got a question, I'll give it to you. 1 decimeter cube. Then what else do we have? It's 1. Yeah, it'll be 1 gram per cc. Cc is centimeter cube. This you might get to use 1000 kg per meter cube depending on units. Chemistry, you'll mostly use kg per liter, gram per ml. And the relation with that is pretty simple. It's the number, you take the same number, numerical value. Some question, if they just want to be random, like decimeter cube to question, then you'll have to touch these, but otherwise 90% of the times you'll get these values. Okay, tell me when you guys have made a note of this. Actually, I'll end the live session. Baki questions, we did 11 out of 28 questions abhi tak. Finish off the remaining time. Okay. We can look at it later. So this is like one major part. This is like the first 1/3 of the chapter. You'll get a lot of numericals based on concentration like this. Iske baad we'll talk all about solubility. So even the topic concepts that we get, Henry's law, Raoult's law, Oswald's law, all of that relates to the solubility. Kaveri, let me know when you're finished, okay?
With what, ma'am?
The noting the density. Done. Once Sia and Smira are done.
I'm done, ma'am.
Okay. Are you also finished? No, okay. हो गया? Arya, how much is left? Finished. Oh, I was actually waiting. Okay. So we'll be talking about solubility now. What do you mean by solubility? Do you guys remember this term? Pehle suna hai?
How much, like how miscible or immiscible a particular solution is?
Yes, basically. How much? Matlab, what is the maximum amount of solute that can be dissolved in a solvent. That is the solute. Like, what is the maximum amount? Why do we say maximum amount? Because this you must be familiar with. There's something called saturated solution. Like, if you keep on, again, this solution matlab kya? Like, the solute particles are occupying spaces in between the solvent particles. So available spaces agar pure fill ho gaye, so you can't put more solute, like you can't dissolve more solute in it. Okay, so that maximum amount of solute that can be dissolved in a solvent at a particular temperature. So solubility depends on what the ambient temperature is, what the temperature of the solvent is. So that's one of the aspects that we'll discuss in this chapter. Okay, so the maximum amount of solute that can be dissolved in a solvent at a particular temperature. So in order to study about solubility, like why maximum solute, chemically kya ho raha hai at that maximum this thing, there are a few terms that we need to discuss. Achha, before that, the units of solubility, like if at all you come across a list of solubility or if you come across this thing, it is measured in like it depends on what you're measuring the solubility of a solid in liquid or if it's a gas in liquid. So for solid in a liquid, the units that we measure is grams per 100 gram of the solvent. In terms of percentage, or I've also come across grams per liter also. These are the units of solubility. How many grams can be dissolved per 100 grams of the solvent, or how many grams can be dissolved in 1 liter of the solvent? Units of solubility. Okay. The cases for a gas dissolving in solid and gas dissolving in a liquid and solid dissolving in a liquid are slightly different. So the reason is that for a gas dissolving in liquid, the effect of temperature is very different from that of a solid. Also, pressure plays a role when it comes to gases. That doesn't come into picture for a solid. So we'll study them separately. So we'll look at a solid dissolving in a liquid. क्या होता है when you dissolve a solid in liquid? First thing is dissolution happens. Dissolution is the process of dissolving essentially. Solute plus solvent, this turns into solution. So as soon as you put salt and water, pehle salt is separate, water is separate. But as time goes by, like the salt starts dissolving in water. It ionizes, occupies the spaces in between water molecules. Then once dissolution happens, this will keep going on and on as you keep adding the salt. At one point, dynamic equilibrium occurs. You guys remember equilibrium from last year? So dynamic equilibrium between solution, like equilibrium matlab forward process hona chahiye, reverse process bhi hona chahiye, right? So that reverse process is basically crystallization. So crystallization is the dissolved substance, the solution turning back into solute plus solvent. Sure, plus solvent, but essentially we talk about when we talk about crystallization, we reference the solute because dissolved state se wapas solid hona, that is crystallization. You're getting the crystal back. So the dynamic equilibrium, so at like when when you get a saturated solution at the point of saturation, the solution is in equilibrium with crystallization. Okay, this is wrong, but you guys know, right? Reversible arrow drop in. Okay, so at the point of saturation, जितना भी dissolve हो रहा है, equal quantity is getting crystallized again. So even if you add more, some of it may be getting into solution, but at the same time, same thing is crystallizing out also. So the net result is what you see it in the real world is और कुछ dissolve नहीं हो रहा है. That's the point of saturation. So there's an equilibrium established between the solution and crystallization. Yeah. So at this point, we say solution is at max solubility. So what is this quantity of the solute required to get to this status, this level? That is the solubility of that solid. Okay. The maximum. So what all factors affect solubility? So this I want you guys to think and tell me. Solubility, affecting solubility matlab, what will increase or decrease the solubility?
Ma'am, what have you written next to dissolution? Solute plus?
Solute plus solvent. अच्छा दिख नहीं रहा है क्या? Oh, chat box.
Solved.
So what are the factors affecting solubility? How do you, like if you need something to
Temperature.
Temperature.
there you go. Since we're talking about solids, how do you think
Nature of
we'll go one by one. Okay, so first temperature. So again, this is exclusively for solid dissolving in liquid. How does temperature affect solubility?
Inversely proportional.
Okay. मतलब when you heat up, solubility decrease होगा.
Increase.
No, wait, solubility will increase. Yeah.
Yeah. Okay, so this is directly proportional. Again,
Yes, if you increase the temperature, solubility will increase.
more often than not, yes. So directly proportional, mostly. But the main point is like it depends. It goes on the basis of Le Chatelier's principle.
What is mostly like?
Because I mean, most of the cases, this is what we observe. But in reality, like you can't take this to be 100% true because it depends on Le Chatelier's principle. अगर exothermic है,
Is that if you increase the temperature, then the kinetic energy will increase, so it will be more soluble.
it does, but also Le Chatelier's principle will come into picture. If that's an exothermic process, so increase in temperature, it may dissolve faster because of the kinetic energy and all. But the quantity of substance that you dissolve,
More, yeah.
yeah. Okay, and if it's like an endothermic thing, then it will increase. So you'll also have to consider Le Chatelier's principle. That is one. Okay. Next,
Pressure.
okay. Does pressure, like, again, we are discussing solid.
Does it affect solid?
So when you're talking about solid being dissolved in liquid, pressure का क्या effect होगा?
no
No
effect.
effect.
No effect. pressure to mostly gases को affect करता है. Like solids are incompressible. It's not gonna affect anything. Liquids are also incompressible. Pressure is not gonna have any effect. What else? Sia was mentioning one thing pehle.
Nature of solute and solvent.
Absolutely. Nature, कितना solute dissolve होगा? That completely depends on nature of solute and solvent. Right?
That above factors affecting, you've written 1, 2, 3, 4. What is that? Like, what are those points under?
So those are just some terms related to solubility. मतलब when you're dissolving a substance, क्या क्या हो रहा है? So dissolution is when solute plus solvent होना चाहिए. Solute plus solvent is dissolving to create a solution. Then a dynamic equilibrium is established between the solute particles and the solution itself. Like जो solution में जा रहा है, जो solution से बाहर आ रहा है. That reverse process is called crystallization. Agar solute particles from dissolved state, if they're coming back to solid state. So crystallization, you denote it as solution gives, separating out into solute plus solvent. So at point of saturation, when you get a saturated solution, dissolution and crystallization are in dynamic equilibrium. So at this point, we say the solution is at maximum solubility.
All these factors, are we only talking about solid and liquid right now?
Yeah. So gas and liquid is a completely different section we'll look at later. Okay, so like nature of solute solvent, matlab, what sort of nature are we looking at?
Like the intermolecular forces.
Yes.
Polar, non-polar.
Polar, non-polar, correct. So polar dissolves polar, and basically like dissolves like. अगर polar solvent है, तो polar में it will be soluble. It will be highly soluble. अगर non-polar substance, अगर polarity कम है, even if it's not completely non-polar, if it is low polar, like low polarity, then solubility also will be less. It's not like it won't dissolve at all. It's not like a 0, 1. It's again a scale. Kitna soluble hai? Highly soluble versus sparingly soluble versus not at all soluble. Like dissolves like. So yeah, so this is all like solution of solid in liquids. Next, solubility of gases and liquids. I'll start from the next class because that's where again our real this thing starts. We're going to have a lot of laws and numericals and questions and a lot of work to do with that. Okay. So abhi ke liye I have assigned a homework, like finish off those 28 questions. I think a couple of more topics also I've assigned to you guys, but that's pretty less, like 4 questions, 2 questions as you guys can finish it. Okay. So ensure that you are well versed with molarity, molality, mole fraction, so that next class we don't have to revisit this. Directly we look at the other concepts. Yeah.